Okay, this is the last section of your notes. I forgot to staple this to the original one. I forgot to even hand this out. So this is the last content for the day, or for the unit. I will give you a study guide at the end of class. You have all day tomorrow for a work day on these problems. Anything else? You have all day Thursday to work on your study guide, and Friday you have a test. T-E-S-T. Okay. S-T. There you go. Yes. You know how to spell it. Very good. So, these are word problems, and second hour this went very well. Last year this went pretty well. I'm going to expect that it goes very well right now. Compounding interest, I want you guys to understand right now that you may not think that you're going to need to know how to use logarithms in real life, but I have numerous examples where I have used this stuff. And my most recent one was I was refinancing my house, and we were going over some compounded interest, and the fact is the banker got it wrong. I had to go back, I had to run the numbers, and I showed her, I said, actually, I should be taking out this other loan. I said, it'll save me probably about $3,000, $4,000, $5,000 over the next few years. And sure enough, yes, she had done her math incorrectly. So next time you think, oh, I'm not going to use this, you might not. It just might cost you a few $1,000s in the long run. So realize that it could be helpful. What does it mean to compound interest? Here's what it means. If you take $100 and invest it at 5% interest, what are you going to have at the end of the year? $105. Now, did you earn that $5? That's a result of interest, right? Now, the next year, you have $105, and that's going to earn 5% interest. So you're going to get another $5 and some cents. So you're going to have about $110 and some cents. Well, it wasn't just your $100 that earned interest. It was also the $5 that you got off of interest. So that's what means compound. It doesn't just work your initial investment. It also, the interest continues to be growing at interest as well. And so that's valuable for you. Now, if it's a credit card, that's totally different. You don't want compound interest developing on what you owe. You want it to be on what you're investing. Now, we have compounded interest. We have continuously compounded interest. What is the difference between these two equations? One's got an E in it. The other one doesn't. That's really the big difference. Now, here's where the E comes from. Watch. I want you to understand this because somebody asked me, where does pi come from? You guys know that pi, 3.141, that's going to be the circumference of a circle that has a radius of 1. Okay? We know that. But where does this E number come from? 2.71. This is where you figure out where it comes from. Okay? The way we calculate the amount of money after a certain time is equal to P, which is principal. What's principal? Your initial investment. Your initial investment times 1 plus whatever the rate is divided by n, the number of times is compounded during that year. So instead of just once, maybe it was twice or 4 times, to the n times t being the amount of time. What I want you to do is I want you to take out your calculator. Okay. And I want you to go to y equals, and we're going to invest $1, parenthesis, times 1 plus, and we're going to have an interest rate of what did I just do? Okay. 1, go 1 divided by x, parentheses, then go to the x. It'll do 1 divided by x before it does the 1 plus. It'll do it. Now, if you go into your table, okay, If I go into my table, watch what happens here. Let's suppose that we compounded it once during the year. That means we plug in 1. You can see the value we get. We get 2. Let's compound it 5 times during the year. 2.48. Let's compound it every week. That's 52. 2.69. Let's compound it every day. 365. How about this? Let's compound it 1,000,000 times during the course of a year. Look at the number you get. If you were to compound it an infinite number of times during the year, compound it continuously, you get the number 2.718, which is exactly the value of E. So, as we show you this right here, where do we come up with the value of E? That is what happens when we compound something continuously. When does something compound continuously? Well, your money in the bank, that might grow once during the year, might get interest once a year. But the bacteria under your fingernails, that grows every second of every day, right? So that's compounding continuously. Let's figure out how to work with these. You guys will do very good at this. Radioactive substance decays in such a way that the amount of mass remaining after t days is given by the function m of t equals 23 e to the negative 0.0043 t, where m of t is measured in kilograms. Okay, so here we have an exponential equation, and it's going to we definitely have some growth and some decay. In this situation, decay, and it's happening continuously, so we have E as being used here. Initial mass. Initial mass is going to occur at what time? What time do we have initial mass? Time 0. So if you want to find the initial mass, take m of 0. What's negative 0.0043 times 0? 0. What's anything to the 0 power? 1. So you end up with m of 0 is equal to 23 times 1, which is... So 23 kilograms is the initial mass. The question is, how much of the mass remains after 21 days? Well, in order to figure out how much mass remains after 21 days, the mass at time 21 is equal to 23 times e to the negative 0.0043 times 21. I have to take out my calculator. 23 e to the negative 0.0043 times 21. 21.01. 1.01 kilograms. So after 21 days, about 2 kilograms has decayed. Did we have to use a logarithm there to solve for that? Nope. Look at the next one, though. After how many days does it have a mass half the initial? What is half the initial mass? Its initial mass is 23, so what's half of that? So 11.5 is equal to 23 e to the negative 0.0043 t. We're wondering at what time. We're trying to solve for time. What time will give me a mass of 11.5? We know that a time of 21 days gives us a mass of 21 kilograms. But we're trying to figure out time there. So now I have to solve that. Question? T. So how do you solve this? We practiced this Friday and yesterday. What do you do first? Divide by 23. So we have 1/2 is equal to e to negative 0.0043 t. I need to access the exponent. I have t in the exponent. How do I get rid of the base e? Natural log of both sides. Very good. So now we're using the stuff that we did the other day. So I have the natural log of 1/2. Anybody have a decimal for natural log of 1/2? Negative 0.693 is equal to negative 0.0043t. And this will go quicker if you guys do the computation for me, so I don't have to go to the board. Divide both sides by negative 0.0043, and you get approximately 161 days. So there's some situations where you can simply just plug in the number and the function will give you the result that you're looking for. There's other times where you have to use logarithms to solve for it, and you need to know what to do when. Any questions? Okay, let's try an easier example. If $1,500 is invested at an interest rate of 8%, compounded semi-annually, find the value of the investment after 5, 10, and 15 years. Well, first let's write an expression for it. I'm going to use this. A of t is equal to principal, times 1 plus r over n to the nt. So that's my formula. And I'm wondering a of 5, a of 10, a of 15. So let's write a function that expresses that, and then we'll actually go to our calculator because that will help us do this a little bit more quickly. What is our principal? What's our initial amount invested? 1,500 times 1 plus, what's the rate? As a decimal, 0.08. Trenton, good to see you. We were just talking about you. Very good. I'll verify it later that you didn't forge it. Compounded semi-annually. So n represents the number of times it's compounded during a year. So how many times is it compounded? If it's compounded semi-annually, that's 2 times. To the 2t. So however many times it's compounded, it says semi-annually, so it's twice a year. We're going to make sure that we divide it by 2 and take it to the second power there. Okay. All right. Let's go to our calculator. And let's plug this in so we can just go to our table and get the 3 values right away. I have 1,500 times parentheses. What's 0.08 divided by 2? 0.04. So I'll have 1.04 to the 2x power. So I just plug it in, and if I go to my table, if you plug in 0, that will give you your initial investment, which was, hey, what's going on here? Oh, see what I did? Does anybody see it? Does anybody see what I did? If I take it to the 2x, it's taking it squared, and then it's multiplying by x. So I have to put it in parentheses. Okay? That's my mistake. So insert parenthesis and parenthesis on the end. That can often cause you an issue. So I go to my table. If I plug in 0, I get 1,500. That's my initial investment. 5 gives me 2,200. If I plug in 10, I get 3,200. If I plug in 15, I get 4,800. So that will give you your results. So what do you have? A of 5, we had 2,220. That'll be the amount of your investment after 5 years. A of 10, what was it, 3,286, something like that. And A of 15 is going to be equal to 4,800 something, 65. So there's your results. So in that situation, you can just plug them in. Any questions? So that's pretty straightforward, right? Let's try something that might be a little bit more difficult from here as you get to your assignment. Flip it over. Okay, it says, which of the given interest rates and compounding periods would provide the best investment? 6% compounded semi-annually, so twice a year. 5% compounded quarterly, so 4 times a year. Or 4% compounded continuously. If somebody told you today that they were going to give you $500 and you could invest it one of the three ways, the highest interest rate, but only compounded twice a year, 5 compounded 4 times a year, or 4% compounded continuously, which one do you think you would take? You say continuously. I agree. That's what I would want as well. Let's verify that that for sure gives us the best investment. It in fact doesn't. It gives us the worst. But let's show why that's true. So then people, sorry, wow, you took that hard. I'm sorry. I didn't mean to make you feel bad. So we don't know what our principal is or anything like that. We have our principal times 1 plus, what's our interest rate for the first one? 0.06 divided by how many times is it compounded in a year? Twice to the 2t. So that's our first scenario. Second one would be our principal times 1 plus 0.05 divided by what? 4 to the 4t power. Not 40, 4t. And the last one, oh, this one's continuously, so how is that different? I use my PERT equation. Okay. So principal times E to the rate is 0.04 times t. Yes, Miss Nelson? I told the Micah story. For you. All right. If she wants to see creepy, she should look at the mirror. All right. Okay. Yeah, I recorded that. What's she gonna do? Come mark up my new wood floor? All right. So, by looking at this, can you tell which one's better? No. Let's try to change this a little bit. If I take if I take 1.03, because that's what this is, right? And I'm going to use up that 2 in the exponent by squaring it. What I end up with 1.0609. So I have the principal times 1.0609 then to the t power. So if I can write these other two using just p and t in this form, then I should be able to tell which one's a better investment. So that one is that. And then I can do another one. I can do, let's see, 0.05 divided by 4. And I want to add 1 to that. And I'm going to take that to the 4th power. I'll use up that exponent. I get 1.0509. And that's going to be to the t power. So right now, which one's better, the 6% or the 5%? 6%'s better. And then the last one, I got to use E, so I will take E2, then I'm going to use up the 0.04 in the exponent. And I get 1.408. So I have P times 1.0408 to the T power. So you can see that, 1.06 is the biggest number, so that's going to grow at the best rate for us. So even though you might be attracted to this compounding continuously, it's not necessarily the best investment. So that's why it pays to know your math and work everything out. Okay? All right. These other three go by pretty quick. Man invests $2,000 in an account, compounded annually at an interest of 5.5%. What is the amount after 4 years, and how long does it take to double? Well, A of t is principal times 1 plus rate over n to the nt power. What is my principal? 2,000. 1 plus, what's my rate? 1055 divided by, how many times is it compounded? annually. So once to the 1 times t. And we're wondering the amount after 4 years. So we'll just plug in 4. So I got 2,000 times 1.055 to the 4th power. 2,477. So after 4 years, it's worth $2,477. The question is, how long does it take for the investment to double? What should I do? If the investment doubles, how much is it worth? 4,000. So we're wondering, when is the investment worth 4,000? Well, the investment is 2,000 times 1.055 to the t power. That's what we're trying to solve for. Trying to solve for time. How do I solve that? Divide by 2,000, I get 2 is equal to 1.055 to the t. How do I get at the exponent? What do I do to both sides? Take the log base 1.055 of both sides. We're going to use that stuff that we've learned earlier. The right-hand side, what am I left with on the right? T. And on the left, how do I figure out log base 1.055 of 2? Good. Log of 2 divided by log of 1.055. 12.95. So it's worth $2,477 after 4 years, and it'll take almost 13 years for it to double. Yeah. All right, an investment of $800 was compounded quarterly over a course of 6 years. The initial investment resulted in $1,245.83. What was the interest rate of the investment? So now we're solving for the interest rate. We have a total investment amount of $1,245.83 equals, what was our initial investment? 800 times 1 plus, do we know my initial rate? No. Do we know how many times it was compounded each year? 4 times. To the 4 times, how many years? 6. So I'm trying to solve for R. That looks difficult. What should I do to both sides? Divide by 800. Somebody 1,245.83 divided by 800. Okay, now I have this expression to the 24th power. Now, people generally don't remember how to do this. And you just got to think back to what you know about mathematics. If I had this problem, x to the 5th is equal to 121. How would you solve x to the 5th is equal to 121? Yeah, you take the 5th root, right? And that would solve it for you. So what do you have to do to this one? Take the 24th root. In order to take the 24th root, what we do is we take 1.56 to the parentheses 1 divided by 24. 1.0187. 1.0187 is equal to 1 plus r over 4. How do I solve for that? Subtract the 1, I get 0.0187 equals r over 4. And we'll do what Bailey says, multiply both sides by 4. And I get 0.075. 0.0748. What is that as a percent? .48%. We don't have time for the last one. Do the last one tomorrow. Sure. As long as your work really shows exactly what you're supposed to do, I'm okay with whatever you round to. Okay, we'll finish that last one off tomorrow. I'll give you a study guide. All day tomorrow is a work day. Other than we'll finish off that problem. And I promise I won't tell you a story. And then all day Thursday, you can work on your study guide. Yeah, so your assignment's right at the bottom here. Some people says 2 assignments. No, it's 1 assignment. It's just 2 different pages. Casey doesn't like that.